Hello everyone, welcome to our YouTube channel AxelBuzz Software Testing, where you will learn in easy simple way. So in last video we saw some testing types and test scenarios of the smart contract testing. So let's continue the previous video here, and in this video we are going to see the remaining testing types and its test scenarios, how to test the smart contracts. So let's get started. Let's see the security testing test scenarios of the smart contract. Input validation. Test the contract with the malicious input such as injection code or overflowing integers or using unexpected data types, and verify that the contract correctly validates and rejects these malicious inputs, preventing the potential vulnerabilities. Access control. Test the scenarios where unauthorized users attempt to access restricted functions or modify sensitive data. Verify that the control enforce the proper access controls, denying unauthorized access attempts. Integer overflow or integer underflow. Test scenarios where the arithmetic operations within the contract could be potentially result in an integer overflow or underflow. Verify that the contract handles these operations correctly, preventing vulnerabilities related to incorrect calculations. Time manipulation. Test scenarios where an attacker attempts to manipulate time-based conditions or deadlines within the contracts. Verify that the contracts implement proper time validation mechanism, preventing manipulation of the time-related operations. Re-entrancy attacks. Test the scenarios where an attacker attempts to exploit the re-entrancy vulnerabilities by repeatedly calling contracts function within a single transaction. Verify that the contracts implement appropriate safeguards such as using check effect interactions, pattern or using mutex locks or to prevent the re-entrancy attacks. Denial of service attack. Test the scenarios where an attacker attempts to overwhelm the contract by consuming excessive resources such as gas, memory, or storage. Verify that the contract includes mitigation techniques such as gas limits, circuit breakers, or rate limits, or to prevent DOS attacks. Front running attacks. Test the scenarios where an attacker attempts to manipulate the order of transaction to gain the unfair advantage. Verify that the contract includes mechanisms such as using commit reveal schemes or random number generation or to mitigate the front running attacks. Cross function or cross contract attack. Test the scenarios where an attacker attempts to exploit the vulnerabilities such as arise from interaction between different functions or contracts within the ecosystem. Verify that the contract handles such interactions securely and prevent the unauthorized or malicious behavior. External contract interaction. Test the scenario where the contract interacts with the external contracts or interfaces. Verify that the contract validates and verifies the integrity of the external calls, preventing potential vulnerabilities or attacks throughout these interactions. Code auditing. Conduct a thorough code review and analysis of the contract's source code. Identify potential security vulnerabilities such as understanding the exception, improper use of cryptographic functions, or insecure data storage and transmission. Interoperability testing of a smart contract. Cross platform compatibility. Test the smart contracts compatibility across the different blockchain platforms like Ethereum, Binance Smart Chain, Polkadot, etc. and verify that the contract can be deployed and interacted with the multiple platforms without any compatibility issue. Cross chain asset transfers. Test scenarios where the assets or tokens are transferred between different blockchain networks using smart contract. Verify that the contract handles cross-chain transfers accurately and securely, ensuring that the assets are transferred correctly between these chains. Chain interoperability protocols. Test the contract's compatibility with the specific chain interoperability protocols like Cosmos, Polkadot, etc. Verify that the contract can interact with the other chains using the defined interoperability standards, allowing seamless communication and data exchange. Cross contract interactions. Test the scenarios where the contracts interact with the other smart contracts deployed on the different chains or the platforms. Verify that the contracts can invoke functions, exchange date, and process the transaction within these external contracts, ensuring interoperability across different contracts. Data exchange and oracles. Test the contract's ability to consume and process the data from external source or oracles. Verify that the contracts can securely retrieve and utilize the external data for its operations, ensuring interoperability with trusted data sources. Consensus mechanism. Test the contract's compatibility with different consensus mechanisms employed by various blockchain networks. Verify that the contract functions correctly within these consensus models, such as proof of work or proof of stake or delegated proof of stake, etc. Cross chain asset standards. Test the contract's compatibility with the asset standards or token standards used on different chains. For example, ERC20, BEP20, NEP5, etc. Verify the contract can interact with the and handle the asset conforming to different standards, allowing seamless integration with other tokens or assets. Transaction serialization and decoding. Test the contract's ability to serialize and decode the transactions across the different chains or platforms. Verify that the contract can accurately interpret and the process transaction data from various formats, ensuring interoperability in the transaction handling. Event broadcasting and subscriptions. Test the contract's ability to broadcast and subscribe to event occurring on the other chains or the platforms. Verify that the contract can publish the events and allow external contracts or systems to subscribe to these events, enabling cross-chain event notifications. Interoperability protocol compliance. Test the contract's adherence to specific interoperability protocols or standards, such as cross chain communication protocols, for example, IBC, etc. Verify that the contract follows the defined protocols and compiles with the interoperability standards, ensuring seamless integration with the other systems or chains. Let's understand the performance testing scenarios of this smart contract. First one is transaction throughput. Test the contract's performance by executing a high volume of transactions within a specified time frame. Measure the number of transactions the contract can handle per second and verify that it meets the expected throughput requirements or not. Gas usage and efficiency. Test the contract's gas consumption during the transaction execution and measure the gas cost for different operations and verify if the contract is optimized for gas efficiency, aiming to minimize the gas usage. Block size and confirmation time. Test the contract's performance under the different block sizes and networks congestion scenarios. Measure the time taken for the transaction to be confirmed and added to a block under verifying network conditions. Scalability and load testing. Test the contract's performance under the high load conditions by simulating a large number of concurrent users or transactions. Measure the contract's response time and verify that if it can handle the expected load without significant degradation in performance. Stress testing. Test the contract's performance by overwhelming it with a significantly higher load than its capacity. Observe how the contract handles the stress condition and verify if it is gracefully recovers or handles the failure in controlled manner. Batch processing. Test the contract's performance when processing a batch of transactions or operations together. Measures the contract's efficiency in handling bulk operations and verify if it can process batches without compromising the performance. Response time. Test the contract's response time for different functions and operations. Measure the time taken for the contract to respond to specific actions and verify if it meets the expected response time requirements. Data storage and retrieval. Test the contract's performance when storing and retrieving the data, especially for contracts with the extensive storage requirement. Measure the time taken to store and retrieve the data and verify that if it meets the expected performance benchmarks. Cold start performance. Test the contract's performance when it is deployed or initialized for the first time. Measure the time taken for the contract to become fully operational from a cold start state. Continuous performance monitoring. Implement continuous performance monitoring of the contract to track its performance over the time. Collect the performance metrics such as response time, usage, transaction throughput, and compare them against defined threshold to identify the performance degradation or improvement. These are the test scenarios aims to evaluate the performance characteristics of the smart contract, including transaction throughput, gas usage, response time, scalability, load handling capabilities, etc. Integration testing of a smart contract. First one, contract deployment and initialization. Test the deployment process of the smart contract on the blockchain network. Verify that the contract is successfully deployed and initialized with the required parameters and initial data. Contract to contract interact. Test the scenarios where the smart contract interacts with the other contracts or external systems and verify that the contract can call the functions, exchange the data, and handles the response from external contracts or the system accurately or not. Data consistency. Test the scenarios where the multiple functions within the contract modify the shared data. Verify that the contract maintains data consistency and integrity, ensuring that the data modifications are synchronized and coherent. Event handling and notifications. Test the contract's event handling mechanism and its ability to meet and receive the events. Verify that the contract emits events correctly and that external system can subscribe and receive the events notification as expected. API and external system integration. Test the scenarios where the smart contracts interact with the external APIs or systems. Verify that the contract can send the request, receive the response, and process the data from external sources accurately. Chainlink Oracle integration. If the contract relies on the Chainlink oracles for external data, then test this the integration with Chainlink oracles. Verify that the contract can interact with the Chainlink oracles, retrieve the external data, and process it correctly. Token standard compatibility. If the contract implements a token standard, for example ERC20, BEP20, then test its compatibility with the wallets, exchanges, or other systems that support the same token standard. Then verify that the contract conforms to the token standard and can seamlessly integrate with the external system supporting the standards. Meta transaction integration. If the contract supports a meta transaction, test its integration with the meta transaction reliers or service providers. Verify that the contract can process and validate the meta transaction received from external relays or service providers accurately. Wallet and DApp integration. Test the integration of smart contract with the different wallets or decentralized applications. Verify that the contract can access and integrated with it and seamlessly using the various wallets or DApps in the ecosystem. Error handling and exception handling. Test the scenarios where the contract encounters error or exceptions during the integration with the external systems or contract to contract interaction. Verify that the contract handles error gracefully, provided appropriate error message, and revert the transaction whenever necessary. Let's understand the regression test scenarios of smart contract. Core functionality. Test the core functions and features of the contract that were previously tested and verified to be working correctly. Verify that these functions still operate as expected after any changes or updated to the contract. Bug fixes. Test the specific areas of the contract that were previously identified as having bugs or issues. Verify that the reported bugs have been fixed and that the contract now functions correctly in those areas. Integration with external systems. Test the integration points of the contract with the external systems or services that were previously validated. Verify that the contract can still interact seamlessly with the external systems after any updates or changes. Compatibility. Test the contract's compatibility with the different versions of the blockchain platform or libraries it depends on. Verify that the contract continues to function correctly with the updated versions and that there are no compatibility issues. Security enhancements. Test the security measures and enhancement implemented in the contract to address previously identified vulnerabilities or weaknesses. Verify that the contract now provide the expected level of security and that the fixes have been effectively mitigated the identified risk. Performance improvement. Test the performance enhancement implemented in the contract to improve the response time, gas efficiency, or scalability. Verify that the contract now performs better and meets the desired performance benchmarks. Boundary conditions. Test the contract with the boundary values or extreme inputs to ensure that it handles these conditions appropriately. Verify that the contract still functions correctly and does not exhibit any unexpected behavior or vulnerability. Regression test suits. Execute a comprehensive regression test suite that covers a critical functions, edge cases, and previously reported issues. Verify that all the test cases in the regression suits pass without any regression or recurrence of the previously identified issues. Automated test scripts. Run the automated scripts that were previously created to validate the contract's functionality. Verify that the automated test provides expected results and that there are no regressions in the contract's behavior. End-to-end test scenarios. Test end-to-end scenarios that involves multiple interaction with the contract, including various functions and workflows. Verify these end-to-end scenarios still functions correctly and ensuring that the contract's behavior is as expected from the start to finish. And this is it for today. In this multiple videos, we learned what are the test scenarios of the smart contract. So hope you enjoyed this video. If you like this video, please hit the like button and subscribe to our channel. We post videos on every Tuesday and Friday. So stay tuned. Happy testing. Bye bye.